How's it, grade 9s? Today we're going on to quadrilaterals, working from slides 1 to 14 from the quadrilaterals PowerPoint. Okay, so initially in these slides, grade 9s, are the properties of your quadrilaterals. In other words, a four-sided shape. I've included a PDF for you that summarizes all of the properties. You need to know those properties off by heart in order to answer these particular types of questions. Okay, so just go through them, write them down in your books, and know them off by heart. Okay, so that is what I'm going to just skip. Like I said, they are in the PDF, and just know them. Okay, now because this is a geometry section, you're going to get a statement column and a reason column. And what I'm going to cover now is the reasons that we use in order to say whatever statement we used. Okay, so reasons for a parallelogram. If you're going to use the opposite sides of a parallelogram are equal or parallel, the reason is opposite sides of palm. Okay, remember we use shorthand for these reasons. Then opposite angles of a parallelogram are equal. You're going to say op angles of palm. Then diagonals of a parallelogram bisect each other, diags of palm. Okay, so everything that I've put here in these blue box are the reasons for those particular things. Okay, moving on to other quadrilaterals. So reasons for other quadrilaterals. If you're saying that the interior angles of a quadrilateral add up to 360, your reason is going to be int angles of quad. Anything to do with the sides of a specific quadrilateral, for example, like a rhombus, a square, a parallelogram, a trapezium, a kite, anything like that, you would say sides of rhombus, or sides of square, or sides of rectangle, or sides of kite, okay, etc. Then anything to do with the diagonals of a specific quadrilateral, you would say diags of rhombus, or diags of square, or diags of rectangle, or diags of kite. Okay. Anything to do with the angles of a specific quadrilateral, opposite angles of rhombus, or op angles of square, op angles of kite, etc. Okay, so this is where it comes into where you need to know the properties of your quadrilaterals. Okay, right, going on to example 1. Example 1 is telling us that PQRS is a rhombus. Now a rhombus is like a special type of square. It's just a square that has been tilted. Okay, they've told us that PS is 15 centimeters. So we know that this side is 15. And PR, this diagonal here, is 24. So I'm just going to put here 24 centimeters. Okay. Calculate with reasons the lengths of the lines represented by lowercase letters. So we need to find the length of that one, this one, and that one. Okay. So first of all, what I can find is Z. Now, one of the properties of a rhombus is the diagonals bisect each other. Okay. Now, bisect just means that they cut each other in half. So, for example, this diagonal here, QS, will bisect this diagonal PR. So if PR is 24 and this QS line cuts it in half, the length of that line would be half of the longer length. So that would be 12. So we know that PR is equal to 12 centimeters. In other words, this is T. TR is equal to 12, okay? But TR is Z, so Z is equal to 12 centimeters. Now, I need to give a reason for this. So if we go back here, I'm going to use this. Anything to do with the diagonals of a specific quadrilateral, I'm going to say diags of a rhombus, okay? So diags of rhombus. Okay, so we've just got the 1 here. We've got that z. Now, like I said, a rhombus is like a square. So it has certain properties of a square. In other words, all the sides will have the same length. Okay, so if this is 15, then that must be 15. That must be 15, and that must be 15. So x must be equal to 15. And what I'm going to do is I'm going to use this one over here. Anything to do with the sides of a specific quadrilateral. And that's what we use there. So I'm going to say here, sides of rhombus. Okay, so we've just got the 1 now, which is y. Now, we know that because this is a rhombus, that these diagonals will be perpendicular to each other. In other words, 90 degrees. Okay, it's just one of the properties of the rhombus. So if I look in this triangle over here now if this is 12, this one must also be 12. And if I redraw that, just a little rough thing for you, we've got a situation like this, where this is 90 degrees. This we've just worked out to be, no, y we don't know, okay? X we've just worked out to be 15. And this one here we know is 12. So this is P, T, Q. I'm looking in this little triangle over here. I can use Pythagoras to find that y, okay? So what first of all I'm going to say is I'm going to say that PT is equal to 12. And I'm just going to say here, diags of rhombus. Okay, now we know that this one is 15. We don't have to state that. We've already proved it. So what I'm going to do now is I'm just going to say in triangle PQT. Remember, we're going to find our hypotenuse, so we know our hypotenuse. And then from the Pythagoras video, you remember I showed you 2 forms of the Pythagoras theorem. So we want to find a side. So we're going to use this form here. QT squared plus PT squared equals PQ squared. And my reason for this is Pythag. Okay, I'm just going to substitute my values in. So QT squared plus PT is 12 equals PQ is 15. Okay, so I'm going to miss a few steps here, grade 9s, but I'm going to show you what I'm going to do. So it's going to be 15 squared. Take this to the other side, it becomes a minus, so it's minus 12 squared, and we get 81. And you remember now what we have to do from this step? We have to take the square root to get the QT on its own. And we get QT is equal to 9. Therefore, y is equal to 9 centimeters, because y is that QT length. All right, moving on to example 2. Example 2 is saying that ABCD is a rectangle. They told us that AEB is 110 degrees. Calculate with reasons the sizes of the angles represented by lowercase letters. So we've got to find that angle there and that angle over there. Okay, so one of the properties of a rectangle, and now again I'm going to stress this, this is why it's important to know the properties of your quadrilaterals. So one of the properties is the diagonals bisect each other. So what that means is we have this diagonal and we have this diagonal. That means that this side will be equal to this side equals that side and that side. They are all equal. They bisect each other. So what that means to us now is this is an isosceles triangle, isosceles triangle, isosceles triangle, and an isosceles triangle, because we have those two sides are equal. Okay, And you remember one of the properties for an isosceles triangle is the opposite angles of those sides would be equal. So what I'm going to do, and I'll just step you through my thought process here, and then we'll work it out. I can work out this A1 angle, okay? And I'll show you in a second how. Once I've got that A1 angle, I can find X, because I know from the properties of a rectangle that this is 90 degrees, okay? So if I have this angle, and I know that this is 90, I just say 90 minus this, and we've got X. Then, how would we find Y? Well, another property of a rectangle is this line is parallel to this line. This line is parallel to that one, okay? So if this line is parallel to this one, I can use alternate angles. I have A1, so I have Y, because I can use that Z, which gives me alternate angles, okay? So let's go through solving this now. So the first thing I'm going to do is I'm going to say that angle A1 equals angle B1. The reason why, angles opposite equal sides, okay? Then I'm going to say in triangle AEB, we have that A1 plus B1 plus 110 degrees will be equal to 180. My reason, angles in a triangle. Now remember, A1 is B1. I've already said that over here. So over here we'll get A1 plus A1 equals, if I take the 110 to the other side, it becomes a minus. So we get 180 minus 110. This gives me 2A1 equals 70. To get the A1 on its own, divide by 2, and we get 35. Okay, so now I know what my A1 angle is. Now, I know that X plus 35 will be equal to 90. Okay, now what did I use there? I used an angle in a rectangle. So if I come back to my reasons here, it's saying here anything to do with interior angles. So we don't want to use that one. Don't want to use that one. Let's just say, I'm just going to say AD perpendicular AB. So AD perpendicular AB. And my reason for that is property of rectangle. Okay. So that means that X is equal to 90 minus 35, and we get 55. All right, so we have X. Now what I'm going to do is I'm going to say that Y is equal to A1, and my reason for that is alternate angles. And I must just state which lines were parallel. AB parallel DC. So Y is equal to 35. Okay. Right, grade 9s. What I would like you to do is exercise 12.3, number 2, and then number 3. You're going to be doing A, C, D, F, I, and J. Thank you.